Okay. Hello, everyone. I'm Josh Grant. Welcome to Beyond Unit Testing, how to uncover blind spots with your Java code. And how to uncover blind spots in your Java code with fuzzing. So I'll start with the agenda, and then I'll have a brief introduction. And then we'll get into it. So today's agenda for this webinar, thank you for joining. I will say, first of all, I do appreciate everyone who joins my webinars. So the agenda today, we'll start with an introduction. What is fuzzing? And then we'll talk about fuzzing in Java, followed by kind of talking about what CI Fuzz is and kind of just having a brief introduction of what CI Fuzz is and how it can be used with Java. And then I'll show a demo. I'll show a demo of how to fuzz CI or how to fuzz Java code with CI Fuzz. Code Intelligence's free command line based fuzzer tool. So your speaker today, hello everybody, I am Josh Grant. I am a developer advocate at Code Intelligence. I've been working in test automation for 12 plus years. I've kind of been up and down the test automation pyramid. I've worked with end-to-end testing using Selenium and Appium. I have worked with API testing in Python, which was really fun. And I'm very happy to be talking at the lowest level of a test automation pyramid, talking about unit testing and fuzz testing today. My language of choice is Python, of course, but we'll be talking about Java today. And I am based in beautiful, lovely Toronto, Ontario, Canada. So thank you for coming. So let's get started. So what is fuzzing? Okay, well, let's take a look at this little fella here. This is an American fuzzy lop, a very common rabbit for being kept as a pet in North America. Nice and fuzzy and fluffy. So American fuzzy lop, or AFL, is also the name of a C++ based fuzz testing tool that came out of Google. Some smart folk at Google came up with this fuzzer. So this is how I want to kind of think of things. You can think of fuzzing as something friendly and fuzzy and warm, but also something that's very sophisticated, used by big places like Google and Microsoft to test and improve their software at scale. So what is fuzzing? Let's talk about the actual definition. So fuzz testing is a test automation technique where random and possibly invalid inputs are generated for a piece of software and then inputted into that software to find bugs and defects. Okay, so what do we mean by random and possibly invalid inputs or fuzzy inputs? So as an example, so let's say we have a piece of software like a function or a method that requires a string as input. The string, this thing, might be considered an example of a fuzzy input. So it's kind of semi-random. It might be generated from kind of based on other strings that are valid to make it invalid. And this is another example because you can see there's a few open braces here. There's a couple of open braces here. Depending on your software, that might be considered invalid. You don't have balanced braces or parentheses. So that might be something considered invalid. So when I think of fuzzing, I think of fuzzy strings. There are other forms of inputs. So you could think of a fuzzy file input if you have a program or a software or a piece of software that takes a JPEG or an image file, takes some kind of markup such as XML or YAML. You could fuzz those files as well, or fuzz the contents of those files, and so on. But a fuzzy string is kind of an easy thing to think of. It's just sort of this random fuzzy looking thing. Okay, so what about inputs? So there's the kind of two sides of it, is generating test inputs and then passing in those inputs. So inputs can be generated efficiently using automation. Fuzzing is a classic use of test automation because what our computer is good at, kind of looping through and sort of generating lots of data or kind of iterating on lots of data. So this is a good use of test automation, and fuzzing techniques lean very heavily on using automation to generate these test inputs or fuzzy inputs. Fuzz testing can also reveal bugs and defects that other techniques, such as unit testing, may fail to find. So fuzz testing is surprisingly effective. Um, just the idea of passing in inputs that are random or semi-random, this can reveal a lot of bugs and be a very good exploratory technique to find a large class of defects in software. Um, Fuzzing can also find a range of, so as I mentioned, a range of issues such as program crashes, memory leaks, and memory corruptions, and data loss. So these are very severe issues, right? If you think of embedded systems and you have an embedded piece of software driving a piece of industrial machinery, like a factory robot or something like this, um, program crashes can lead to kind of hardware malfunction and can reveal safety issues, right? So like this could put this could cause physical harm, this could cause damage, but also memory leaks can also be very severe as well. Being able to access sort of parts of disk that you're not supposed to, all these kinds of things. So fuzzing can find issues that are very severe, that are very mission critical, if you will. So I have a bit of a mathematics background. Fuzz testing, came out of a dark and stormy night at, I believe, the University of Illinois computer science department. So, like mathematics, fuzz testing is unreasonably effective. Fuzz testing can actually be very effective at finding very severe bugs relatively quickly. So, so some basics. So let's get back to what is fuzzing. So let's talk about some basics. So fuzzers need some form of fuzzy input creation. So there's kind of broadly, there's two ways that you can generate fuzzy data. So you can generate fuzzy data from scratch. So you kind of say, give me a string or give me a file or give me some input from scratch. So you just start from a basic seed or basic input and you generate the inputs kind of from nothing over and over again. So this is one approach. And another approach is to take existing data, which could be valid. So take an existing string, take an existing file input, and then sort of tweak or modify it in some way to make it fuzzy. So this is also related to the concept of mutation testing from computer science, where program inputs are mutated. So you can kind of mutate, make a small tweak or perturbation, and then use that as fuzzy inputs. So these are both approaches that are used. And so on top of generating fuzzy data, you can also execute and input fuzz testing kind of in three different ways. Like if you think of the system under test and the relationship and what you know about the system under test, there's three different approaches. If you are a software tester, you'll be very familiar with black box testing, where there is no knowledge of the internals of the system. So this kind of comes from the expression black boxes on airplanes. If an airplane crashes, black boxes just reveal information around what was happening at the time, but you don't know exactly what was happening. So similar to that, black box testing is where you just have inputs and outputs. You don't know the internals of a system. You don't have access to the internals of a system. You just can explore it by passing inputs and seeing how the software or program reacts. In contrast, on the other side of things, there's white box testing, where you know all of the internals of a piece of software. So an example of this is test-driven development, where a developer is writing code. So you not only have access to the system, but you're actively working with the software under test. And you're testing it, knowing exactly all the internals. So you know exactly what the code does. You can modify the code, etc. And then somewhere in between is gray box testing. So gray box testing is an important technique in software testing, but also in fuzz testing, where you have some knowledge of the internals of a system, or you have some kind of instrumentation that gives you a little bit of the internals between black and white box testing. So these are kind of the three kind of ways to think about how you approach testing a piece of software, fuzzing or otherwise. And let me just take a look, time check here. Okay. Okay. Sorry. Okay. So sorry about that. Okay. So white, black, and gray box testing. Um, so speaking of gray box testing, and the reason I bring it up is that one highly effective approach to gray box testing is feedback-based fuzzing. So feedback-based fuzzing. So going back to the dark and stormy night, fuzzing started out with just randomly generating inputs or semi-randomly generating inputs, and sort of trying to find bugs based on those inputs. So feedback-based fuzzing is a technique where the outputs of previous iterations are used to sort of are fed back into inputs into the system. So this is again classic test automation. Instead of just blindly passing in random values, we a feedback-based technique is where outputs are fed back into to modify inputs and to create better input test cases. So you can kind of guide your you can guide your fuzz testing towards certain better fuzzy inputs to reveal bugs, either a larger class of bugs or to guide towards bugs a little more quickly. So feedback-based fuzzers, like I said, can find many classes of bugs and very quickly in just a few seconds. If you have an off-the-shelf laptop as a developer these days, in a few seconds you can find some pretty severe bugs using feedback-based fuzzing. So pretty cool. All right, so fuzzing in Java. So here's a frothy cup of, I mean, I don't think we want a fuzzy cup of Java, but I don't know, frothy cup of Java. So let's talk about, again, kind of historically. So fuzzing historically has been used for testing software that is memory unsafe, where bugs or security vulnerabilities can be executed through undefined behavior, untrusted inputs. So when you think of sort of memory unsafe languages, or where you have to kind of manually, or you are able to manually manipulate low-level system hardware and system memory, I think about languages like C and C++. So these are kind of the classic, sort of, depending how you think about it, low-level programming languages. So C and C++ are both close to the metal. And because of this, because they're very close to computer hardware, they both have manual memory management. Many fuzzing tools focus on these languages, right? So in C++, for example, it's very easy to either access parts of memory that you're not supposed to. It's very easy to write software that you can create data corruption, or you can do certain things that are sort of untrusted or are not good, sort of at the memory level. So fuzzers focus on this, and there's a very large class of fuzzers that focus on C and C++, like AFL, American Fuzzy Lop, and also CI Fuzz. So Java does not have the same issues that C and C++ have. So for example, Java has automatic memory management garbage collection. There's no concept of malloc and free in Java. And also Java does not directly access the bare metal. So in Java, the idea of use the value at this address in memory, or allocate values at these specific addresses on the disk isn't really a thing. So this provides a lot of safety. And this in turn allows Java to avoid a large class of issues present in C++. So you don't have to worry about sort of not freeing or freeing up memory that you're not supposed to. So Java kind of handles all this really well through the JVM, right? It's one of the nice things about Java. So if you don't have memory management issues and you don't have these sorts of things, how can we use fuzzing in Java, right? If a large class of issues don't apply to kind of manually working with memory or working with the disk, what can we do in Java in terms of fuzzing? So let's go up a level, or go up a little bit, and talk about kind of what bugs fuzzing can find. So fuzzing is an effective technique for finding all sorts of software bugs, including functional bugs and security bugs or vulnerabilities, right? In some cases, these might coincide. Depending on who you are, you might think of a program crash as a functional bug, or you might think of a program crash as a security vulnerability, right? And also, even though Java is in a way more secure or more safe, memory safe, than C and C++, security bugs are still a big deal in the Java world, even if you're not thinking of embedded software, or even if you're not thinking of sort of system software. You're thinking of web development, or you're thinking of like web backends, or you're thinking of data processing, ETL loops, those sorts of things. Security vulnerabilities and bugs are still a big issue. So, for example, around 12 months ago, you might have heard of Log4j. There was a critical CVE, and Log4j had this issue where you could have a remote code execution. So it was possible to take a Log4j code and pop a shell using and this was really to like also a vulnerability called Log4Shell. Log4j is as old as the hills. It's a logger in Java. From my experience, I've worked on a few different Java code bases, and just Log4j just ends up in there. It's just one of those dependencies. It's just always around. Despite all this, it's still produced a recent CVE at a very severe remote code execution. Something else, if you're working with databases, HyperSQL, also recently, maybe a few months ago, there was a critical CVE with remote code execution possible through this. Again, very common library, sort of a common helper or common library working with various web backends. So there's all that. So security still an issue in Java. You still want to find these security bugs, even if they're not present at the sort of low language level. So why else would you use fuzzing in Java? Why else would you consider fuzzing? Well, so there are other techniques for finding functional or security bugs. Functional testing in Java could be a good thing. You could use unit testing to determine whether the functionality of your testing or your code is good. There are a whole plethora of security tools like scanners and proxies to reveal security issues. But the good thing about fuzzing is if you use fuzzing, why not look for both? Why not try to find functional and security bugs at the same time? In this world of shifting left and focusing on left and development, why not look for both? All right, so the demo. So that's kind of enough of the theory that's going on, and why we're here, why we're talking about fuzzing. So for this demo, okay, sorry, sorry. Hi. Little reference from Love Actually. So let's shift gears into code demo. So let's show me the code. So this will be a demo based in Java. And this will be showing CI Fuzz, Code Intelligence tool for fuzzing Java code from the command line. It's a great little tool. So I will be using examples from this project. Definitely please check this out. Code Intelligence Road Smart. It's on GitHub, freely available. Clone it down, take a look. In this example, I will be using Java JDK 17, but all of the code I've written in this project is Java 8 compatible. So it should work Java 8 all the way up to 17. I'll be using Maven as my dependency management. I'll be using IntelliJ, my preferred IDE. I'll also be using JUnit 5. We love JUnit 5. We love JUnit. JUnit 4 has also been tested and will work as well. And last and certainly not least, we will be using the CI Fuzz CLI. Please download this here. You can get this. You can install from command line. You can also install from GitHub. Please take a look. It's a good tool, something to play around with. All right. And so what am I going to cover in this demo? So I will cover two examples using CI Fuzz. So one, I will be finding an out-of-memory exception in an array-based operation. So this is kind of a functional bug. probably not a high security issue. It's sort of a bug that could happen when you're processing arrays in Java or even other ways. And then I'll be using CI Fuzz to find a SQL injection due to untrusted input. So this is a classic security issue, something that can be found pretty readily using CI Fuzz. So without further ado, let's take a look. All right, so let's get out of this. I will transition as smoothly as possible. Perfect. Okay, so here's my application, and I will make this a little bigger. So this is, let's do this. Okay, so here's my main application. It is a very basic, very buggy command line based application called RoadSmart. So it is a CRUD based application for inputting and outputting data related to major highways and major roads in various parts of the world. So let's see what it does just for completeness. So I'm going to run this. Oh, look. So welcome to RoadSmart, the intelligent tool for getting road information. So maybe I want to read all the roads. What's in this database? So here's some roads. Pacific Coast Highway, I-95, 401, Bundesautobahn in Germany. So these are some roads. Maybe I want to add a new one. So can I create one? Yes, I can. So I'm going to have, in addition to the 401, there's the 402, both major highways in Ontario and Canada. And this is in Canada. So I do this, and then I can also read. And then I'll see I've added down here the 401 with some information around speed limits and length of the highway. So, and then I can also print. Maybe I can print this to XML. Maybe there's some kind of output format that is preferred. So it's a realistic application, a little simple, but the kind of thing you might use Java for. So what are some code in here? So let's take a look. So here is a piece of code, again, kind of trivial kind of thing where you might have this analyzer class, and the analyzer class has a method where you process an array. Maybe it's a complicated processing operation. You have to do some kind of, element by element management of what's going on in your input. So I have this thing. And so I kind of follow this classic pattern of I'm going to take this array input. I'm going to make a copy of this array, make a copy of it piecewise or element-wise, and then I'll process the copy. Now, of course, I'm just doubling every value. It's an array of integers, but imagine this is something like very complicated. So this looks straightforward. There is a very subtle, I think, a very subtle bug somewhere in this code. It's 20 lines of Java, which isn't very much. So you can take a look and try to guess where the you could try to guess where this bug is. Again, making an array, make a copy, sort of element-wise copy, and then do some kind of processing, and then return the output. So so I've written this. It's excellent code, I think. Let's test it. So I've written a test here. Let's just get rid of this for a moment. So let's say I think, okay, I want to make sure that this code works. So I will write a unit test. Could maybe test-driven development, right? Like very good advice. Write a unit test to understand what your code is doing. So I create an instance of this analyzer, and so I arrange some kind of version of this analyzer to execute, and then I'm going to make this like this. Okay. So I'm going to arrange some kind of fixture to test. I'm going to perform an action. So I'm going to call my complex processing method using some kind of input. And I'm going to compare it to some kind of expected input versus an actual output of the actual method under test. And then I'm going to assert that this action, or I'm going to assert that something is correct. So maybe the input array needs to preserve size. So if I have 3 elements in the input, I should have 3 elements in the output. So let's run this and see what I get. And it runs and passes. So like I've written a unit test. Things look good. I've checked sizes, right? Like so far, so good. But I still have this bug. So let me So, so what I'm going to do is, in addition to this unit test, which just tests the functionality of this method under test, I can also fuzz this. I can also create a fuzz test. So again, this is in Java. This is in the same class. And so what I'm going to do to generate this, I'm going to use my CI Fuzz. So I've installed CI Fuzz. You can definitely take a look at the installation. CI Fuzz, create, and I'm going to create a Java fuzz test. And it creates this test stub, my class fuzz test 1. So this is now located in the root of my project. Okay, and this is just a fuzz. This is just a stub. So I can copy and paste this and add in some details as needed. The two things that this provides me that's very helpful are the fuzz test annotation. So this tells JUnit that like this is actually a fuzz test. So handle this differently from an at test from a standard JUnit. From a standard JUnit unit test. And I also get this fuzz data provider. So this is the key. This is the thing that will help me generate those fuzzy inputs. So, and I will just get rid of this. So imagine that I have cleaned all this up. Here's delete. There we go. I've cleaned all this up and moved this into my unit test class. And so now I have this fuzz test. So again, I follow the same kind of pattern. I'm going to create a fixture, this analyzer class under test. And then I'm going to call this method that I'd like to test. And I'm going to use this fuzz data provider to pass in some kind of int, right? This is what I'm looking for. I'm looking for some kind of array of integers. And so this data provider can provide that functionality. It can say, okay, give me an array of integers. I could also get an array of strings, a single string, an int, et cetera, et cetera. But in this case, I need an array of integers. And so then I'm going to run this from CI Fuzz. So CI Fuzz command line. So CI Fuzz run, and I'm going to call my class name. So analyzer test. So this builds and runs in kind of a standard way, but then it also runs this additional fuzzing process, right? So this executes, great. And look, CI Fuzz has a finding. It finds an issue. It gives that issue a name. It gives it some kind of name so that you can reference that later. Kind of standard SecOps kind of a way to go. And it provides an out of memory issue. So I've found an issue, I found an error, and I found my out of memory error. Let's see where that bug is. I know you've been waiting with bated breath. So the bug is on line 15. So very subtle bug, easy to miss, particularly if you think about like maybe this is code you haven't written, maybe you're new to a code base. This really should be incrementing this way, right? You should really be going through and incrementing your position sort of, +1. But instead of calling the actual position, the bug is calling the reference to the array. So this could get wildly out of hand, right? Like if this value becomes an integer like 40 or 50, this could kind of grow. There's also sort of use case, or there could be test cases, like imagine you have inputs of an array of zeros. So this will just keep going back to 0, and then this infinite loop will just continue, or this loop will become infinite and always kind of walk through. So that's where the error is. And again, subtle error, functional error. If you want to think of this as an error that a developer would make in development, it's something that anyone could do. But CI Fuzz was able to find this in pretty short order. So that's really good. So definitely take a look. So again, definitely take a look at the examples in that GitHub repo. You can run this yourself, set it all up. You can kind of take a look and kind of try this yourself as well. So So moving along into, so that's kind of a functional bug. It's something a unit test may or may not have caught, but CI Fuzz caught it again in just a few seconds. So let's take a look at SQL injection. So here we have a class. I'm going to close all this up. So here we have a class again. So we have this CRUD application. And again, just for demonstration purposes, I'm using an in-memory database. Of course, you want to persist your data somewhere on a disk somewhere, but for this case, I'm just going to use it in memory, but it works exactly the same. So I have this information database class, and this handles various operations I might want to do with my database. This creates an initial database. It inserts a few values like here. Again, these could come from some other data source. Maybe there's an existing database that you migrate your data from, or maybe there's a CSV file that is used to generate things. But there's also some additional functionality here. So like you can insert road data based on a road object, right? It's pretty good, Java way to go is, pass objects around and communicate via objects. But you can insert data, you could read all data, select star from roads, the kind of classic, like get all the information, and delete. So like there's some kind of things in here, and it's relatively, similar to how you might code things in real life, right? You might have some kind of database operation where you're pulling things out or inserting data, that kind of thing. So here I want to, just zone out a little bit. So here I have my information database fuzz test. This also creates a unit test as well. And it's got some setup and all this kind of business here. But what I really want to look at is comparing these two tests. So following the same pattern as before, we have a unit test to verify, like, can I insert, and this might be the very first unit test that you write. If you're test driving something, you might want to say, can I insert data? Can I insert data into my SQL database somehow? If you're sort of working with a legacy code base and you're thinking, I need to get a handle on this, I need to understand how this works, you write a unit test to, can I insert data in a way that I expect? So this is a unit test to verify the functionality of inserting data. Again, we're talking about SQL. So I have these two actions here where I arrange my test fixtures. So I initialize a database instance or access a database instance. And then I create a test road, right? A fixture, pass in like a valid string. And this is, I'm just using a static or fixed string data for this, right? All I'm doing is saying, okay, give me this object. The object has a string. The string is valid and it's fixed and it's static. So I kind of I arrange my fixtures. I perform an action. Can I insert this road data? So I act, and then I have an assertion. So I assert. Did my result work? Was it able to insert properly? Assert true. And so let's run this. Runs and passes, right? So far so good. Maybe I'm a developer and I'm a backend developer and I just want to be able to insert my test data, and go home and have some nice glue wine, this kind of thing. So functionally, this gives me some confidence that this works, that my information database class kind of works the way I think it does with respect to inserting data. But I'm also going to write the same. And if you look like line by line, the setup is exactly the same for this fuzz test. So I'm going to have my fuzz test annotation provided by the JUnit package from Code Intelligence. And I have my fuzzed data provider. So this actually provides my fuzzy data to input things. So I set up my database and instantiate it somehow. Here, and I'm going to do exactly the same steps. I create a road fixture, and then I perform my insertion operation, and then, did my insertion operation work, right? Do I get the result I expect? The key difference, these are line by line exactly the same. sort of an arrange, act, assert, so-called AAA unit test. Same structure for the fuzz test. The difference is instead of using fixed or sort of constant data, I'm going to use generated fuzz data. So I'm going to have my fuzzy data inserted here into my test fixture and then pass that into my method under test. So, and because I'm in IntelliJ, I've cleverly set up, and I'll show you this. So in addition to running standard JUnit tests, I also have a shell script. So instead of going to the command line every time, I've just set up CI Fuzz run with my test file, or I guess, yeah, my test class file. So I can just run it right from the comfort of my command line. So I'm going to do that. Okay, so I'm going to click this and run up here. So this builds, Maven does some things, it runs and checks, and let's see what I get. And I get a SQL injection. So again, in a few seconds, I have a piece of software using SQL, and that SQL seems to work. I'm able to insert data appropriately. Sorry, I have some junior colleagues that are joining down here, very junior colleagues. But while this works functionally and my unit tests do provide some value in seeing, that my inputting works, or my data insertion works, I'm able to use fuzz testing to reveal a SQL injection. And if I go back and take a look, you'll see that the SQL injection makes sense. I'm basically just inputting values via string. I'm not doing any sort of prepared statements or any data sanitation. I'm just trusting the user input. These row get name, get country are just strings. They could be malicious. It's possible that these strings are sort of maladapted to drop data or to kind of perform unexpected actions with my database. So yeah, like dropping tables, dropping databases, performing malicious inserts or data collection, that kind of thing. So yes, so I'm able to find this SQL injection in short order using CI Fuzz. So that's pretty good. And again, this example also fully available. You can definitely run it from the GitHub project as well, kind of play around with it, and pull requests and issues welcome. So those are the two examples, kind of a functional test and a SQL. All right, and so with that, so yeah, walk through the edit memory, walk through the SQL injection, and that kind of concludes the webinar. So thank you for joining. I will be around for a few minutes for questions. So thank you very much. All right. All right. So there is one question. Just can I explain the difference between black box and white box testing a bit more? Of course I can. So white box testing is where you have full internals. You have access to the internals of a piece of software. So you can see all of, or you can see, yeah, basically you can see all of the code in a method or a class. Maybe you have access to the entire repository. So you can kind of actively see and look for, bugs in your software. So for example, you can review code and think, oh, maybe this method looks like it could be vulnerable to some kind of security issue, or like this method looks, this class like has a lot of methods, I should test them, this kind of thing, right? You can kind of just look through and sort of explore based on more information. Black box testing kind of takes the opposite thing, where it's like I can pass in given inputs to my piece of software and then observe what the outputs are. So again, this you could take a very exploratory approach Maybe it's a third-party piece of software. Maybe it's something on another team that you don't have access to. You can't see the internals for a variety of reasons. And so you just have to test sort of inputting and outputting. So both are valid approaches for testing. And you can also apply fuzz testing and unit testing to both. And of course, they complement each other. Any other questions? I'm sure people are looking forward to the holiday period where they get to sort of, take it easy. All right. So yes, that kind of wraps it up. Thank you again. So definitely please check out the link to CI Fuzz, the CI Fuzz command line tool. You can use it against your very own code. There's a variety of examples in Road Smart, the project that I mentioned. It's free to download, free to use. Just it's totally free. No requirements there. It will work with C++. If you've got some C++ or C code hanging around, try that out. But definitely take a look at Java as well.